This example is about match sample in Excel. Let's look at the data first. This problem is about a treatment medication to reduce blood pressure. So we've selected at random a certain number of individuals, patients, and before they went on the medication, the baseline blood pressure was measured. Then they went on the medication, and after the treatment was over, the new blood pressure was measured. So for each sample subject, there is a baseline blood pressure reading and then a new blood pressure reading. So there is a match sample, okay, same number of observations, both samples. So now we're going to define what x sub 1 and x sub 2 are. So x sub 1 is the baseline blood pressure reading. And x sub 2 is the new blood pressure reading, and these are matched. So the difference D is defined as x sub 1 minus x sub 2. So that is the difference in BP reading between the baseline BP and the new BP. So now we define mu sub D as the average difference in BP reading before and after the regimen of medication. We want to see whether the medication is helpful. So if the medication is helpful, the new blood pressure reading should be smaller than the baseline blood pressure reading. So in other words, mu sub D must be greater. Mu sub D measures the amount of reduction in blood pressure that is achieved. So we want to see whether the alternative hypothesis is greater than 0. We have a positive reduction in the blood pressure. So null hypothesis then is less than or equal to 0. So now we can run data analysis. So data analysis. If you look for matched pair, so Excel calls it paired two sample for means, which is the same thing as matched samples. So select that. Now value 1 range is your baseline BP, and second variable range is new BP. They both must be exactly the same size for match sample to work, otherwise you will get an error. The hypothesis difference is 0 and the output is this. Click OK. Format. And you get the same type of output like before. Okay. So now the two means, and the two variances, and the observations, and then you get Pearson's correlation also between the two variables. We'll talk about correlations later. And hypothesis difference in the mean is 0. Then n minus 1, see the common sample size of 60, n minus 1 is the degrees of freedom. This is the t statistic, and here are the two p-values, one for one-tailed test and one for two-tailed test. And this is a one-tailed test, so p-value is that. Let's use proper formats. Let's convert this to percentage and see it's pretty close to 0. So our conclusion is, since the p-value is less than 5%, reject H sub 0. And the interpretation, a two-part interpretation. First about the conclusion, so we have sufficient sample evidence to conclude the average difference in BP reading before and after medication is greater than 0. The probability this conclusion is wrong is nearly 0. So this is not exactly 0, so though it appears to be 0, but in statistics it cannot be exactly equal to 0. So if you go far enough, you will find that it has, there you saw it. So there is a non-zero digit there. So justify text. Let's put this back to